Hi guys, so this is Mrs. Lavoie and today we are starting a new unit on coordinate geometry. So a lot of the rules and formulas that we used in algebra are going to come into play in this unit. So this is really just a review today of slope formula, equations of lines, writing the equation of a line and finding the slope of a line from a graph and putting lines onto graphs given the equation. Most everything in Delta Math is going to ask you for the equation of the line in slope-intercept form. So I have that down here, y equals mx plus b. That's the easiest form to put on a graph. So that'll be what we're going to kind of stick to for most of this unit. Slope formula, this is rise over run. Right? Rise is along the y-axis, so it's the difference in the y-coordinates. Run is along the x-axis, so it's the difference in the x-coordinates. So you have to put the y's on top or your slope is going to be wrong. Okay? So something like this, I can just use this formula here. Slope is also called m a lot of times because that's what we use in the equation, y equals mx plus b. So I'm just going to put m equals, and then this will be my x1, y1, x2, y2, my 2 points on the line. And of course, if I have a graph, I could just count rise over run between those 2 points because this is the rise and this is the run. But if I don't have a graph, then this formula will work just fine. So I'm going to do 12 minus 13 on top. And then I'm going to do negative 18 minus negative 15 on bottom. And of course, when I minus the negative, that's going to change to a positive. So I'm going to get negative 1 on top, and then I'm going to get negative 3 on the bottom. And negative over negative, that will cancel to positive 1/3. So positive 1/3 would be rise 1, run 3. So it's a slightly uphill line, sort of like that. Okay? All right, now let's do this one. M equals, again, I'll do y2 minus y1 on top, x2 minus x1 on the bottom, so 13 minus 1 over 3 minus 8. So this will be 12 on top equals negative 5 on the bottom. So this is a negative slope. It's going to be going rise 12, run negative 5. So it's going to be a pretty steep downhill sloped line like this. Now remember, if you have a line that is horizontal, that has a 0 slope, okay? I always talk about Vux Hoi here, right? Hoi, that means horizontal lines have a 0 slope. Their equation is always y equals something, right? And then of course vertical lines, this is where our Vux comes in. Vertical lines have an undefined slope, and their equation is always x equals something. These two aren't going to follow that standard form of an equation as easily as the other lines are going to. So yeah, so this would be an undefined slope. So we could have a 0 slope, an undefined slope, a negative slope, like we do here, or a positive slope. Now if it's a negative slope, the negative can go on top or bottom, but not both, because if it's on both, then they cancel each other out like it did right here. Okay? If I have the graph, I can still use this formula. I can find, okay, well, what is this point here? Let's call it A. A is going to be at negative 2, negative 2. And what is this point here? We can call that B. That'll be at 3, comma, negative 3. And I can still do this formula. Or when I have the graph, I can just count. I can start at A and go towards B. This would be rise negative 1, run 5, right? Or I could start at B and go to A. This would be rise positive 1, run negative 5, right? So it's the same thing. Like I said, the negative can be on top or bottom, but not both. Or it can even be out to the side like this, right? That's how we usually see it. All right, so if I had put this into the formula, y minus y, I would have gotten negative 1 on top, x minus x, I would have gotten 5 on the bottom. So I would have gotten the same answer using the formula or just counting on the graph. So same thing here. If I want to count from A to B, I would be rise 1, run 2, right? Or if I wanted to go from B to A, that would be rise -1, run -2, and of course that cancels out to the 1/2. Okay, so if I want to put these two coordinates into a formula, the coordinate for A is going to be 0, -1. The coordinate for B is going to be 2, 0, right? So if I did y minus y, I would get 1 on top, x minus x, I would get 2 on the bottom. So either way, it comes out the same way. All right, we also need to know how to write the equation for these lines if we're given a graph, and I'm going to use this formula, y equals mx plus b. So the x and y are in your equation. They're part of your equation. M is the slope, and then b is the y-intercept. So for this particular equation, I know that the slope is -1/5, right? So I'm going to write it as y equals -1/5 x plus b. Now b is my y-intercept. You can see that that's it's kind of hard to see here because it's between the lines, right? This one's much easier to see because it's right on the line. This one's a little bit harder. So then I have to say, okay, well, where does it really hit this y-intercept, right? I'm not really sure where it hits. So if that happens, chances are it's probably going to be easier to figure out what b is by using our point-slope equation of a line. So point-slope equation of a line is y minus y1 equals m times x minus x1, okay? We still need the x and the y in here to make the equation, but we're going to use one of the points to find out what this b value should be here. So I'm just going to use this first point, -2, -2, and I'm going to plug it in here. So let me change colors here so it'll be a little easier to see. So y minus y1 will be -2, so I'm going to change that to a +2 because I'm doing minus a minus or minus a negative, equals m, we know the slope, times x minus, and then my x1 is also -2, so minus a -2 would change to a +2. Now, this doesn't look like this. This one has y all by itself. So I need to go ahead and rearrange this to get it in terms of y. So I'm going to do that. So y plus 2 equals -1/5 x minus 2/5. I just distributed that to both terms, okay? And then I'm going to have to subtract this 2 to the other side. And when I subtract 2 from this side, it just cancels out. But when I subtract 2 from this side, well, it's hard because I have to have a common denominator. What is -2/5 minus 2? Well, in terms of fifths, this would be 10/5, right? So I'm going to change that to 10/5 so that I have a common denominator. And now I'm doing -2/5 minus 10/5, which is -12/5. And so now my equation will look like the y equals mx plus b format, right? So this answer here should be -12/5, okay? So look at where it hits. What is -12/5? Well, it's like 2 2/5. So past the 2, that look like about 2 2/5. It does. So that would be that equation. Now, ordinarily, if you have the point crossing right on a line, right on a grid mark, you don't have to go through all of that. You can just pick out the y-intercept from here. And I believe on tonight's Delta Math, it'll be as easy as that, just picking out your y-intercept from the graph and not necessarily going through this point-slope format equation of a line, okay? So let's see, if I were doing the equation over here, we'll have y equals m, we said was 1/2 x plus b, and of course I can see it hits at -1, so it'll just be a -1. You might also see this written as y equals x over 2 minus 1. Same thing, slope of 1/2, just like you might see this one written as y equals -x over 5 instead of -1/5 x, same thing. Okay, so we can write the equation from a graph, we can find the slope using the formula or just counting rise over run. And we also need to know how to be able to graph a line on a grid, okay? So if it looks like this, that looks just like my y equals mx plus b format, so that's pretty easy. All I have to do is start with my b, 5. I know that's my y-intercept, so I go to 5 on my y-intercept. And then I've got m is -4. Well, slope is always rise over run, so this must be -4 over 1. So my rise is -4, 1, 2, 3, 4, and my run is +1. Rise -4, run +1. So you can see where that line is going to end up. This one, it doesn't look like this, right? It's not in this y equals mx plus b form. This is really the easiest form to graph. So let's make this look like this. All I have to do is solve for y. So I'm going to get y by itself in this equation. Let's subtract 5x to the other side of the equation. So I'll have -3y equals -5x plus 3. All I did was I subtracted that 5x over to the other side of the equation, right? Okay, and now I need to get y by itself by dividing everything by -3. Everything by -3. So these will cancel, and I'll have y. The negatives will cancel here, and I'll just have 5/3 x. And then these will cancel, and I'll be left with -1. So now it's in this y equals mx plus b format, which is really friendly. Now I can take my y-intercept, which is -1, put a dot there, and I can take my slope, rise over run, rise 5, run 3. Rise 1, 2, 3, 4, 5, run 3, and then if I try to do it again, it's going to go off the page. So let me go the other direction. 1, 2, 3, 4, 5, 1, 2, 3. There we go. Remember, rise -5, run -3 is the same as rise +5, run +3. Okay? So hopefully you get the idea there. Okay, I have a few more that we can graph here. Again, we want to get it in this format because that's the easiest form to graph. So let's solve for y. Let's subtract this 4x over to the other side. And then let's divide everything by 3. That'll get y by itself. So I end up with y equals -4/3 x, or -4x over 3. The x can be on top because that is x over 1. There is no y-intercept here. So my y-intercept is 0. It's essentially like having a +0 here, right? So it's going right through the origin, right? And then this is my rise over run. So rise -4, run 3. Rise -4, run 3. That's the same as rise 4, run -3. Because remember, that sign could be on the top or the bottom, just not both. So there's that line. Okay, this one, y equals mx plus b. It doesn't even have an m. There's no x in there, right? So it does have a b, 4, but this is one of those ones that because it doesn't have an x and a y, it doesn't follow the format as much. So I always use this Vux-Hoy trick, right? So this is a y equals equation, so it's a Hoy line. That means it's going to be a horizontal line with a 0 slope. Horizontal line with a 0 slope. And it's going to cross the y-axis at 4. So crossing the y-axis at 4, horizontal line with a 0 slope. Okay? This one, again, not in the right format. Let's get y by itself. So I'm going to subtract that x over to the other side. Okay? My y-intercept will be -4. I can put a dot there. My slope is -1, which again, that has to be rise over run. So rise over run must be -1 over 1, right? So I'm going to rise -1, run 1. Rise -1, run 1. I can continue that in the other direction as well. So here's my line. There's another one that doesn't follow the format, right? It doesn't follow that y equals mx plus b format. It is a Vux-Hoy problem, right? And this particular one is an x equals equation. So it's going to be a vertical line with an undefined slope. Vertical line with an undefined slope crossing the x-axis at 1. So like that. So hopefully that gives you a refresher on what you learned in Algebra 1. That's going to be the majority of what we're using in this unit in geometry. Thanks, guys.